Okay, welcome to my channel. Now in this video, we want to evaluate this integral, the integral from square root of 2 to positive infinity of 1 over x plus x raised to the power of the square root of 2. Okay, so yeah, this really looks bad. Okay, square root of 2 as a power, not even square root of x, just square root of 2 as a power. Well, we're just going to do this real quick because it's not that bad. We're going to start off with the general form. Yeah, I just want to give us a general form of this, all right, so that when we evaluate the general form, we can just come to this particular example and just get it done. Okay, so let's look at it. Let's suppose that we have the integral. Okay, let's say from a to b. All right, let's assume that this function is nice enough, or this bounce is nice enough, okay, for this function to, for the integral of this function to be defined on that. All right, so this is supposed to be some arbitrary power. So let's put some arbitrary power, let's say n, okay, where n is some arbitrary number. All right, maybe say some real number, or n is every real number. Well, I'm not really sure. You know, since we're just saying n is just an arbitrary number, so let's not put any real number. Let's just say n, where n is any real number. We have that in our mind, all right, but we don't know whether it will be defined for every real number. So let's just keep there and then see what we have. And maybe in the process we are going to know, all right. So the first thing I'd like to do here is to factor out x raised to the power of n from the denominator. So we're going to have 1 at the top, factor out x raised to the power of n. Okay, so we are going to have, when we factor out x raised to the power of n from this will be x raised to the power of 1 minus n, okay, because we've just subtracted n from 1, that is the powers, and then we are going to add it to it. Well, here we'll just be left with 1. Okay, so we put the dx over here. Well, the next thing we'd like to do is a u sub. You can say let u be 1 plus x raised to the power of 1 minus n. When you differentiate that, we're going to have 1 minus n, okay? Let's see, we're going to have 1 minus n, then x raised to the power of negative n. Okay, so that tells us that if we multiply the numerator and denominator by x raised to the power of negative n, let's say we multiply this by x raised to the power of negative n, x the same, so we add the powers, n minus n will be 0, so everything here will become 1, right? So multiply something with 1, we just get that thing. So the power here is x raised to the power of negative n, and also motivated by the derivative of this denominator, we can multiply the numerator of this by 1 minus n, which will be the coefficient that will come down when this is differentiated. And since we have multiplied by that, let's balance it by dividing it by the same thing we just multiplied, which is 1 minus n, right? So what that tells us is that if we differentiate this denominator, x raised to the power of 1 minus n plus 1, the derivative of 1 will give us 0. The derivative of x raised to the power of 1 minus n will give us 1 minus n, then x raised to the power of negative n, because we are going to subtract 1 from 1 minus n. That will give us negative n dx. So that means that this will become 1 over 1 minus n, all right, times the natural logarithm of this denominator, which is 1 plus x raised to the power of 1 minus n. And how are we sure we will not need absolute values? Anyway, let's just put it. Okay. All right, and this is a bound of integration, so we take that from a to b. All right. Well. Now notice something. This is 1 minus n in the denominator. So that means if n is every real number, if n is 1, this will be undefined, all right? Or maybe this will diverge, if you want to put it that way. So that means we should not allow n to be 1. Is there any other thing we should take note of? This is plus, and x should be on a positive interval. Yeah. Okay, x should be positive. Well, yeah, that should be nice enough. Anyway, this works. So let's say n should be not be 1. So we should say n should be every real number except the singleton 1. All right. Okay, that's great. So we are going to apply this general form, okay, in solving this problem here. So we have this. So let's equate this to, well, from the thing we have, know that n has replaced square root of 2. So we are just going to put that. Then b and a are infinity and square root of 2 respectively. So this will now become 1 over 1 minus n here, which is just the square root of 2 from the given problem, all right, here. And then we take that times, well, we take the natural logarithm of the absolute value of, well, we have 1 plus x raised to the power of 1 minus n, where n here is the square root of 2. So we have 1 plus x raised to the power of 1 minus the square root of 2, all right? Okay, so we close that, and then we have to take that from a to b, which is from square root of 2 to positive infinity. Okay, so let's see what that will give us. Well, so looking at positive infinity, we are looking at the limit, okay, the limit as x approaches positive infinity. Well, to substitute the bounds, when we look at the limit as x approaches positive infinity, what would that be? Well, as x approaches positive infinity, notice that this is 1 minus the square root of 2. 1 minus the square root of 2 is going to be less than 0 because square root of 2 is bigger than 1. It's around 1.4 something. So since it is bigger than 1, 1 minus that will give us negative 0 point something, of course. X raised to the power of some negative number. As x approaches infinity, in fact, this will be breaking down to 0. Alright? So we'll be having 1 plus 0. So natural logarithm of 1 plus 0. So let me put this out here. This space is for this one. So we're going to have natural logarithm of 1 plus 0, which is natural logarithm of 1. Of course, that's just 0. We subtract. Well, we're going to take the natural logarithm of, we substitute x equals to square root of 2. We're going to have 1 plus, in place of x, we're going to have the square root of 2. Alright, so we have the square root of 2 here. And we're raising that to the power of 1 minus the square root of 2. Okay, so you take note of that. Well, why did I keep a space here? I want to rationalize the denominator a little bit. So I want to multiply top and bottom by 1 plus the square root of 2. When we multiply top by 1 plus the square root of 2, we are going to have just 1 plus the square root of 2, since the top is just 1 already. When we multiply the denominator, let's see, 1 times 1 will give us 1. The negative square root of 2 times positive square root of 2 will give us negative 2. Right? Great. Okay. So this is it. Well, this can be written as 1 plus the square root of 2. Let me put it down here. 1 plus the square root of 2. You know, the denominator is just negative. So, yeah. The denominator is just negative 1. Well, the natural logarithm of 1 is 0. Negative 1 times this negative will give us positive. So, we have natural logarithm of 1 plus the square root of 2. Okay, and this square root of 2 is raised to the power of 1 minus the square root of 2. Wow, this is really, really irrational. Can the square root of, no, I don't think natural logarithm can neutralize the square root of 2. Anyway, this is good. We can stop here, alright? We can stop here. I don't think this squared bracket is necessary, but that's a good place to stop. Black Michael Pen. Anyway, that is it. Alright? Okay, thanks for watching, and please subscribe to my channel, share this with your friends, share this video with your friends, and I'll see you in our next video.